decomposition of functions. Next, I want to teach you what do we mean by invertible functions. What is the condition for a function to have its inverse, f inverse? Now, before I formally define which functions are invertible and how to find the inverse of it, let me take a simple example. Okay. What happened that once a particular person comes to Delhi and want to meet a student who happens to be his friend's son. He goes to the hostel but somehow forget the name of the student. Then the warden asks him that unless you tell me the name of the student, how can I help you? Even that is a difficult job because there are hundreds of students living in my hostel. He says, but sir, I know the room number. Okay, tell me the room number. Sir, he lives in room number 4. Let's see if we could find out the student. This is the situation. F1 is a function from set A to B. A is set of students, A, B, C, D, E, and B is the set of numbers, room numbers, hostel room numbers. 1, 2, 3, 4. Let me confine 4 rooms. A is the set of students, as I said, and B is the set of hostel rooms, and F1 is a function which associates to each student a unique room. You know our function, each student can occupy only one and only one room. Okay, and this is the situation. Student A lives in room number 1, B shares room number 1 with him, C lives in one room 2, room number 2, D and E both share room number 3. Now the guest want to see a student living in which room? Room number 4, he said. That I want to meet a student who lives in room number 4. So when the warden checks up with the room list, he finds that nobody lives in room number 4. He says, sorry sir, there is nobody in room number 4. Okay, so better you find out in hostel 2. Now by the way, mathematically speaking, in types of functions, which type of function is this? It is many one into. This is a many one into function. Okay, because A and B both are sharing room number 1 and room number 4 is vacant. This is many one into function. So for a particular room number, no room, no student correspond to it. Now he goes to hostel number 2. Let's see what is the situation in F2. You know already A denotes the set of students, B denotes the hostel room numbers, and in hostel A, B, C, D, just like that I say A, B, C, D are the students. Room number 1, 2, 3, 4 is there. A lives in room number 1, B lives in room number 2, C is being allotted room number 3, D and E both share room number 4. So when he goes to hostel number 2 and says, I want to meet a student living in room number 4, he says, okay, let me check. But he says, sir, there are 2 students living in room number 4. Can you give me a bit of idea about the 2 students? He says, I'm sorry, I can't recognize. I know that he lives in room number 4. He said, then better you go to the single-seated rooms. Okay, this is not necessarily, what in terms of function, what kind of function is this? This is no doubt many one on 2 function. This is a many one on 2 functions. All the rooms are occupied, but some sharing is there. So the gentleman goes to the 3rd hostel. Let's see what is happening in 3rd hostel. In 3rd hostel, the students are say A, B, C, D, 4 students, and the set B room number, there are room number 1, 2, 3, 4, 5. A is being allotted room number 1, B stays in room number 2, C is there in room number 3, and D in room number 5. So when he goes to the 3rd hostel, the warden says, sorry sir, nobody lives in room number 4. What kind of function is this? This is 1, 1, though it is a single seated. That means to each student there is a room, and if you know the room number, we could work out the student, because it is a single seated. But the problem is, room number 4, nobody lives. What kind of function you call it? This is 1, 1, single seated of course, but into function, 1, 1 into function. So then the warden says, I am sure you go to the last hostel and you will find the student you want to meet. Let's see what is the situation in the last hostel. Consider F4. A is the set of students A, B, C, D, E. B is the set of rooms 1, 2, 3, 4, 5. And as the warden told him that look, this is a single seated, fully occupied hostel. And how is it? Say straightforward, A lives in room number 1, B in 2, C in 3, D in 4, E in 5. The gentlemen want to meet a student living in room number 4. So naturally in room number 4 who lives? D. FD. When I say FD is 4, that means F image, the student D lives in which room? 4. But he wanted that in room number 4 who lives? Student D. And not only in room number 4, in any of the rooms 1, 2, 3, 4, 5, if you want to work out which student live in a particular room, you just need to know the room number and you know the student. That means in each student there is a particular, each student has been allotted a particular room, and each room there correspond only one and only one student. And by the way, what kind of function is this? This is 1, 1 on 2. This is a 1, 1 on 2 kind of function. So if we have 1, 1 on 2 kind of function, then only to each student there will correspond a unique room, and to each room there corresponds a unique student, and that further formally we will study, then only we can define the invertible functions. Now in continuation of what I have discussed with you, that f is a function from say this time set x to y, where x is set of students and y is the set of hostel rooms. Let us very formally, speak about this particular example and then conclude that when a function is said to be invertible, what is the condition for a function to be invertible. Take this example afresh. Let f is a function from set x to y. X denotes the set of students, say A, B, C, D, set of students, and y denotes the set of hostel rooms, say 1, 2, 3, 4, and we already defined that f is 1, 1 on 2. F is 1, 1 on 2. And for simplicity's sake, let A is allotted room number 1, B stays in room number 2, C is occupying room number 3, and D is asked to go to room number 4. This is the situation. This is a 1, 1 on 2 function. And then another function G is defined from set Y to set X, where already Y is the set of rooms 1, 2, 3, 4, and X is the set of students A, B, C, D. So when G is defined from say set Y to X, correspondence you already know that student 1 lives in room number 1, or who lives in room number 1? Student A. Who lives in room number 2? Student B. Who is there in room number 3? Student C. And in room number 4D. So G is being defined like this. And now consider GOF, the composite function GOF. Now just see what do you mean by GOF of X. GOF of X means G of fx. Now before I conclude that what kind of function this GOF of X is, let me take examples. That is, what is GOF? And you know that GOF is from what? From f is there from x to y and g is there from y to x. So x to y and y to x. So g of f will be a function defined from what? From x to itself. G of f this time is a function from x to itself. Just see what is the g of f image of element A. That means g of fa. Fa means student A lives in which room? Room number 1. And what do you mean by G1? That in room number 1 who lives? In room number 1 A lives. That is G of f image of A is A itself. Similarly, I can prove that G of f image after all this will be B. That of B will be B. C will remain C. And D is D. What do you call such kind of function? To such kind of function where to every element has the same image as itself, you call identity function. Okay. So what is GOF of x? GOF of x is IX, identity function on x. That is each element of set each element of set x is associated to itself. Okay, and now let's see FOG. FOG. Now FOG, f is a function from x to y, g is a function from y to x. So when you want to apply GOF, so first it will be g y to x and then f x to y. So can you tell me that GOF will be a function from what? It will be a function such that from y to y to itself. From room number, it will come back to room number. So now let's see. What is FOG of say room number 1? By that you mean f of G1. Who stays in room number 1? Student A. So f of A means student A lives in which room number? 1. So FOG of 1 comes back to 1. Similarly, can you verify that FOG of 2 will come back to 2 and so on? So we can conclude that FOG of x is again x, comes back to the same element, and we can call it FOG. Instead x, if I define symbol y, FOG of y is IY. FOG of y is IY. That means FOG gives you the identity function on set y, and this is also 1, 1 on 2. So, and in such a case, we can say, I repeat, that if FOG is IY and GOF is IX, both of them are identity functions on x and y sets, then we say that the function f is invertible, and in that case g is defined as f inverse. If I repeat, if GOF is IX, that means to each element x it gives back to the same element, and FOG on y gives back to y itself. In that case we say that the function f is invertible and g is said to be f inverse. So what is the condition for a function to be invertible? That there should exist another function g such that GOF is IX and FOG is IY. And also, it could also be taken like this, that f should be 1, 1 on 2, then only it will be invertible. So, to prove that a particular function is invertible or not, either we can check that it is 1, 1 or 2, or we could find out another function g such that FOG and GOF both are identity function, and then g is said to be f inverse. And now let me formally define what do you mean by invertible function or inverse of a function f denoted by f inverse. How do you define? If there exists a function g, you already know f is a function from set x to y. Given is a function f such that f to y is said to be invertible. If there exists another function g from y to x such that GOF is Ix and FOG is Iy, then the function g is said to be inverse of f, denoted by f inverse. I repeat that given is a function f such that x to y, and if there exists a function g such that y to x, such that GOF is identity function x and FOG is identity function y, then the function g is said to be inverse of f and denoted by f inverse. Now here you must note one more thing, that a function f is invertible if and only if it is f is 1, 1 on 2. So if we have to verify that particular function is invertible or not, we can also prove it 1, 1 on 2 and justify that yes, it is invertible.